Hello children, I hope you're staying safe at home. To continue with the study of gas laws, today I'm going to talk about Charles' law. I hope you watched the last upload where I had explained Boyle's law. So, Charles' law explains the relationship between temperature and volume in gases. This relationship can be explained when we leave an inflated balloon in the sunlight. After some times, what happens? This balloon will burst. So, why is it bursting? Because the air inside the balloon expands, the volume is expanding with rise in temperature. So that means if there is an increase in temperature, there will also be an increase in volume. Okay, we are talking about the gas which is present inside the air which is present inside the balloon. So in 1787, Jacques Charles studied the temperature-volume relationship of gases, and experimentally it was found that a fixed mass of any gas expanded or contracted by 1 by 273 of its volume. Okay, and when did it contract or expand? For each degree Celsius rise or fall in temperature, and of course the pressure was taken constant. So Charles' law formulated his law which states that pressure remaining constant, the volume of a given mass of dry gas, it increases or decreases by 1 by 273 of its volume at 0 degrees Celsius for each degree rise or fall in temperature. Okay, so you need to learn Charles' law by heart. Now moving on to the mathematical expression of Charles' law. Okay, we take the volume of a fixed mass of gas at 0 degrees Celsius as V0 and volume of a fixed mass of gas at T degrees Celsius as V. Okay, so according to Charles' law, V will be equal to the volume at 0 degrees Celsius plus there is a rise of 1 by 273 into the temperature. Okay, remember the pressure is constant. So V will be equal to, when we take V0 as common, 1 plus T by 273. Okay, so further taking the LCM as 273, we get 273 plus T, which will be equal to by 273 into T. This T is equal to 273 plus T. Okay, so for a given mass of gas at 0 degrees Celsius by 273 is always a constant. Okay, that is your K. So volume is directly proportional to the temperature. This is your constant K. Okay, so volume is directly proportional to temperature. Okay, and if you cross multiply and change it into the constant V by T, changing the proportional sign into equal to sign, you will get a constant K. Okay, so Charles' law is also restated as volume of a given mass of dry gas is directly proportional to its absolute temperature. So it's directly proportional to its absolute temperature, provided the pressure remains constant. Okay, now suppose a gas occupies V1 centimeter cube at T1 temperature and V2 centimeter cube at T2 temperature. So you know, according to Child's law, volume is directly proportional to temperature. So when we change the proportional sign into equal to sign, it is multiplied by a constant k, and into T1. Therefore, V1 by T1 is equal to constant K. Okay. Similarly, V2 is also directly proportional to T2. So V2 will be equal to a constant K into T2. V2 by T2 is equal to K. That is the constant. Here also constant. That means V1 by T1 is equal to V2 by T2. Okay. So therefore V1 by T1 is equal to V2 by T2, which is K, and remember the pressure is always constant. Okay. So this is the Charles law equation. Okay. Now, according to this equation, if the temperature is doubled, then what happens to the volume? The volume will also be doubled. Okay? Volume will also be doubled. And similarly, if the temperature becomes halved, what will happen to the volume? The volume will also become halved. Okay? Next, we move on to the graphical representation of Charles' law. So what do? We take volume in this axis and temperature in this axis. Okay, in degree Celsius. So you know, as the temperature increases, the volume will increase. So you can see a straight line is formed. So you can see at each step, as the temperature rises, the volume is also increasing. Okay, a straight line is obtained when relationship between volume and temperature of a gas is plotted on a graph. Okay, so we use a general term which is known as isobar. Isobar means at constant pressure. Okay, so the next graph here shows you again the relationship between volume given in this direction, in this axis, and temperature, which is given in this axis. So this graph is showing isobars at constant temperature, the isobars, okay, which is extended backwards to show the 0 point. Okay, now moving on to the explanation of Charles' law in terms of molecular motion, kinetic theory. You know, according to the kinetic theory, the average kinetic energy is directly proportional to its absolute temperature. Okay, so supposing when the temperature of a gas is increased, supposing there are molecules of gas or fixed amount of gas inside your fixed mass, and you heat it. Okay, that means you are increasing the temperature. What will happen? Each molecule will gain kinetic energy. It will start moving faster and faster, and then it will strike the walls of the container more vigorously and more frequently. Because why? They have gained kinetic energy. And if the pressure is kept constant, volume also increases. Hence, at constant pressure, volume of a given mass of gas is directly proportional to temperature, which is your Charles' law. Okay, now the significance of Charles' law: volume of a given mass of gas is, of course, you know, according to gas law, is directly proportional to its temperature. Volume is directly proportional to its temperature. If temperature increases, volume also increases. If temperature decreases, then volume also decreases. Okay, so what happens to the density then in this case? That means when the temperature is rising, the volume is becoming more. That means density is becoming less. It is becoming less dense. Why? Because the molecules if they are close together, they will gain kinetic energy and then they will move far apart from each other. So what is happening to the density? It is becoming less. Okay, so this is the reason why hot air is filled into balloons used for meteorological purposes. Okay, now next, moving on to the absolute zero. Okay, so according to Kelvin, if the temperature of a gas at 0 degrees Celsius is lowered to minus 273 degrees Celsius, volume will become zero. All molecular motion will stop. But of course, this is only theoretical. It is not possible because gas is one of the states of matter and it will have some mass and volume. So the temperature, this temperature minus 273 degree Kelvin is known as absolute zero. The absolute zero. Okay. So all gases liquefy or solidify before reaching this temperature. Either they become a liquid, either they become a solid. So this temperature has not yet been reached theoretically. Okay, so theoretically this is the lowest temperature that can be ever reached. At this temperature, I told you, all molecular motion will cease, kinetic energy becomes zero, but practically speaking, this temperature is impossible to reach. Okay, now the temperature scale with its 0 at minus 273.15 degrees Celsius. But of course, for calculation purposes, we take only minus 273 degrees Celsius. Okay, and whose each degree is equal to 1 degree on the Celsius scale only. 1 degree on the Celsius scale is called the Kelvin or absolute scale of temperature. Okay, now next, moving on to the standard temperature and pressure, STP, also known as normal temperature and pressure. So remember, the standard temperature is 0 degrees Celsius, which is equal to 273 Kelvin. The standard pressure is 760 millimeter Hg, which is equal to 76 centimeter Hg, which is equal to 1 atmosphere pressure. So any change in the pressure or temperature changes the volume of a gas. So when you express the specific volume of a gas, it is necessary to say, tell both its pressure and its temperature. Okay, so more or less the theoretical portion of this chapter is over. Okay, sometimes the effect of moisture on pressure. If you remember the vapor pressure that you did in some of the sums that you solved in this chapter, like some gases like nitrogen and hydrogen, which are insoluble or very less soluble in water, slightly soluble in water, if they are collected over water, then what happens? With the gas, water vapor is also present. Okay, so the total pressure, that is water vapor, okay, and plus the gas is there. Okay, so when we talk about the total pressure, then you have to add the pressure of the water vapor as well as the pressure of the gas. Okay, so the total pressure exerted by this moist gas is equal to the sum of the partial pressure, that is the partial pressure is the pressure that the gas would exert if it was there in the absence of water vapor. Okay, so the partial pressure of water vapor is also known as aqueous tension. Okay, so with this we come to the end of this chapter. Go through it and work whatever work I will let you know in your WhatsApp group. Have a nice day, children. God bless you.